Welcome to Simultaneous Equations Level 4. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving y equals 5 minus 2x and 3x plus 2y equals 7. Now, since the first equation is written with y as the subject, the easiest way to solve these equations is by substitution. And this means that because we know that y is equal to 5 minus 2x from the first equation, we can take this and substitute it for y in the second equation. So the second equation, 3x plus 2y is equal to 7, becomes 3x plus 2 times, and we can now replace the y with 5 minus 2x from the first equation, and that's still equal to 7. Now this equation just has x's in, we can solve it normally, and we can start by expanding the bracket. So this becomes 3x plus 2 times 5 is 10, and 2 multiplied by minus 2x is minus 4x, and that's equal to 7. We can now simplify the left by collecting together the like terms, and these are the 3x and the minus 4x, and because 3x minus 4x is minus x or minus 1x, this becomes minus x plus 10 is equal to 7. We can continue solving now by removing the plus 10 from the left, and we can do this by using its inverse, which is minus 10, and doing the same on the right. On the left, the plus 10 and the minus 10 cancel out to leave us with minus x, and on the right, 7 minus 10 is minus 3. Finally, if minus x is equal to minus 3, we know that x must be equal to 3. So x equals 3 is the first part of our solution. To find the value of y, we can now use the first equation again, because this already has y as a subject. So y is equal to 5 minus 2x, and we can replace the x with 3, because we now know that x is equal to 3. So y is equal to 5 minus 2 times 3. Minus 2 times 3 is minus 6, so this becomes y equals 5 minus 6, and since 5 minus 6 is minus 1, we have y is equal to minus 1. So this means that our final solution to problem 1 is x equals 3, y equals minus 1. In problem 2, we're solving 3x plus 4y equals 14 and y equals 2 plus x. Now again, since the second equation is written with y as a subject, the easiest way to solve this is to solve by substitution. And so we're going to take the 2 plus x, which we know is equal to y, and substitute it for y in the top equation. So the top equation, 3x plus 4y is equal to 14, now becomes 3x plus 4 multiplied by 2 plus x, and that needs to go in brackets, is equal to 14. We can now solve by first expanding the brackets. So 3x plus 4 times 2 is 8, and 4 times x is plus 4x is equal to 14. And on the left, we can now collect together the like terms. So we have 3x plus 4x, which gives us 7x. So the left becomes 7x plus 8 is equal to 14. We can continue solving by removing the plus 8 from the left, and we can do this by subtracting 8 from the left and doing the same on the right. And on the left, the plus 8 and the minus 8 cancel out to leave us with 7x. And on the right, 14 minus 8 is 6. Finally, we can remove the times 7 from in front of the x, and we can do this by dividing by 7 and doing the same on the right. And on the left, the times 7 and the divide by 7 cancel out to leave us with x. And on the right, 6 divided by 7 can just be written as 6 over 7, or 6 sevenths. So x is equal to 6 over 7. To find the value of y, we can now take the second equation, y equals 2 plus x, and substitute x back into this. And this is the best equation to use because y is already the subject, and that's what we're looking for. So if we replace x with 6 sevenths, we get y equals 2 plus 6 sevenths. And since 2 plus 6 sevenths gives us 20 over 7, y is equal to 20 over 7. And this means that our final solution to problem 2 is x is equal to 6 over 7, y is equal to 20 over 7. In problem 3, we're asked to find the coordinates of the point where the lines with equations 2x plus 5y equals 61 and x equals 2y minus 1 meet. Now when we're asked to find the coordinates of where two lines meet, what we need to do is solve their equations simultaneously to come up with an x and a y value that work in both, and then write these as coordinates. So looking at the two equations, we can see that the second equation is written with x as a subject, and so we can solve this by substitution. And starting with x equals 2y minus 1, we can replace the x in the first equation with 2y minus 1. So the first equation, 2x plus 5y is equal to 61, becomes 2 multiplied by 2y minus 1, because we've substituted the x for 2y minus 1, plus 5y is equal to 61. We've now got everything in terms of y, so we can expand, simplify and solve. So starting with the bracket, we have 2 times 2y is 4y, and 2 times minus 1 is minus 2. We have a plus 5y at the end, and this is still equal to 61. Now on the left, we can simplify by collecting together the like terms, and we have 4y plus 5y, which gives us 9y. So the left becomes 9y minus 2, and that's still equal to 61. We can now continue solving by removing the minus 2 from the left, and we can do this by using its inverse, which is plus 2, and doing the same on the right. And on the left, the minus 2 and the plus 2 cancel out to leave us with 9y, and on the right, 61 plus 2 is 63. To now remove the times 9 from in front of the y, we can divide by 9 and do the same on the right, and on the left the times 9 and the divide by 9 cancel out to leave us with y, and on the right 63 divided by 9 gives us 7. So y equals 7 is the first part of our solution. To find the value of x, we now take the second equation, because x is written here as the subject, and we substitute y for 7. So x is equal to 2 times 7 minus 1. 2 times 7 is 14, so this becomes x equals 14 minus 1, and 14 minus 1 is 13, so x is equal to 13. Now we now need to write this as a coordinate, and so we know that these two lines are going to meet at the point where the x coordinate is 13 and the y coordinate is 7. So the point 13, 7 is our final answer to this problem.